In order to graph this ellipse like we did in the last couple videos, we're going to want to rewrite this so that we're in standard form. So this one's not too terrible to do. We're going to take a look in another video how to do this if we have a little more work to do with complete the square, but in this case it's really not that bad. First thing I'll do is I'm going to add that 100 over to the other side so that my x squared and y squared terms are alone on the left side of the equation. Because we hopefully remember that standard form of an ellipse means that we're equal to 1, I'm going to want to divide everything by 100 so that this part over here becomes just a 1. So let's go through and divide everything by 100. And then simplify our result. So 4 over 100, if you think of that fraction right there, 4 over 100 is the same thing as 1 over 25 if we simplify. So that becomes just x squared over 25, which is looking more like we expect an equation of an ellipse to look like. Second fraction is 25 over 100. That fraction simplifies to 1 over 4. So y squared over 4. And of course 100 divided by 100 is just 1. And so voila, just like that, we're now in standard form. So using that, I can now graph this using similar procedures to what we did in the previous couple of videos. So first up, let's go ahead and find the center of the ellipse. Everything's based around that center. So the center this time is convenient. It's at 0, 0. There is no h and k values. X and y are by themselves. So the center of my ellipse is going to be right at the origin, right at 0, 0. Next up, the a and the b values. Well, a squared is always the bigger of the two values, at least the way I do it. So a must be 5, the square root of 25, and b must be 2, the square root of 4. And so those give me, I like to think of them as the long radius and the short radius. I guess more accurate name is the semi-major and semi-minor axis, but whatever. So let's see. So since the a squared value is underneath the x direction, or x variable, what that tells me is that this ellipse is going to be more stretched out in the horizontal or x direction. So from your center, let's count 5 spaces left and right. So 1, 2, 3, 4, 5. That's going to be the location of one of your vertices, and then count left 5, 1, 2, 3, 4, 5. That's going to be your other vertice. And I'm going to jot those 2 coordinates down so I have them, because I'm going to want them by the time I'm done. So 5, 0, and then negative 5, 0 are the 2 vertices. The vertices are always on the longer axis, the major axis. Let's do the same for the b value. Since the b squared value is underneath the y, I'm going to be less stretched in the y, or the vertical direction. So short radius is the way I think of it. So up 2 and down 2 from the center. We call those points the co-vertices. So those values would be 0, 2. And 0, negative 2 for the 2 vertices. So I've got just about everything I need here. Well, I guess let's graph the ellipse real quick. So do my best to make that round and not pointy. So I'd say that's not too terrible. So I've got just about everything I need. I've got the graph, I've got the center, I've got the vertices, I've got the co-vertices. All that's left are the foci, or the foci, or the focuses, whatever you want to call them. To find these values, I need to use the formula c squared, c is the distance from the center to the focus, is equal to a squared minus b squared. So I have those a squared and b squared values back at the beginning, back in my equation. So I've got c squared equals 25 minus 4. If I subtract those values, I see that c squared is equal to 21. And if I take a square root, I get the square root of 21. Now, I would try to simplify that if I could. I can't break that down any further. So I've got that value. Well, it doesn't help me too much if I want to graph the point, but it's a very accurate answer. Let's see. So the way that I would want to label these, foci, is they're going to be along the major axis, so whether that's vertical or horizontal, whichever one is longer. So I can see that I'm going to have to count up and down 0. I just need to know how far left, how far right from the center I need to count. Well, since our center was at 0, 0, I'm going to have to count the square root of 21 spaces to the left, and then up and down 0. And I'd have to count negative square root of 21 spaces to the left, 0. So there's my 2 exact values. I don't really know where those are if I wanted to graph those, so I guess let's use a calculator and get an approximate value for those. And I see that comes out to be about 4.58, which obviously that's much easier to graph than the square root of 21, unless you happen to know what the square root of 21 is. So plotting those 2 points, then I like to do this step just to make sure that I didn't make a mistake and that my foci are indeed inside the ellipse. So if you count 4.58 spaces, you'd be probably right about there. for one of your foci, and then probably right about there for the other. So I can see that those are right along the major axis. I've got exact values, I've got approximate values, I've got them graphed. I'd say I've done all I can do with this problem.